another video session. In this video session, I'm going to explain you the selection sort algorithm. This is the second sorting algorithm we are studying in lectures 11. The first sorting algorithm was bubble sort. The second one is selection sort. Let's see how this selection sort algorithm works. The selection sort algorithm repeatedly performs these two operations which I'm going to explain you. The first operation is selecting the minimum from the unsorted sub-array. This means when the initial input array is taken, we consider the whole array as the unsorted subarray. As we progress over many iterations of this algorithm, a part of the array will be sorted, another part will be unsorted. Okay, so the first operation is selecting the minimum or maximum. You select minimum if you want to sort the array into ascending order, and you will select instead maximum if you are trying to sort the given array into descending order. Okay, with a slight change we can always modify from sorting from ascending order to descending order. The second thing is, once you select minimum or maximum, you will swap that minimum or maximum with the first position of the unsorted subarray. Now these two operations will be repeated not just one time, several times, starting from position 0, which is considered as the first position of the unsorted subarray, all the way up to until the I value becomes less than n minus 1. We will understand this even more with great details as we progress through the example now. Okay, so let me consider an array of n elements, 6 elements here. N is equal to 6 because there are 6 elements. You can see here the input array is random array. Okay, now the first operation for position I equal to 0 is this. First thing is we need to select the minimum from the entire array, because this is the first step. The entire array is actually unsorted subarray. So when we select the minimum, you can see here in the last video we understood how to compute the minimum or maximum. So here we will use the same algorithm. The algorithm says that at position 1 we have the minimum, which is 0. Once we select the minimum, what we are going to do is we are going to swap it with the first position of the unsorted subarray. The first position of the unsorted subarray is actually indicated by whatever the value of I we are currently in. Okay, so that value has been swapped. Now we have to repeat the same thing for I equal to 1, 2, 3 and 4. When it comes to 5, the array would have been already sorted, and we will not repeat that process for this single location. Okay, we will see that as we progress now. Now the selection sort for I equal to 1. You please note that this part of the array is considered to be sorted, and now this part of the array is the unsorted subarray. We will repeat the same thing. We'll consider this part of the array, the subarray, this part, and we will find the minimum in this part, and we will replace that minimum with the first position of the unsorted subarray. This is the first position of the unsorted subarray. Okay, let's do that. The minimum is again from position 3. We will swap it with position 1, which is the first position of the unsorted subarray. Okay, and this completes the processing for I equal to 1. Now we are in I equal to 2. Now again I repeat it. This is the unsorted subarray. Okay, now again we will repeat the same process. We will find the minimum, and then we will swap it with the first location of the unsorted subarray, which is indicated by I, and then we will repeat the same thing for position I equal to 3, which is, this algorithm is very simple algorithm, especially because we have already understood how to find the minimum or maximum from a given array or subarray. Now we will find the minimum from this part of the subarray. The minimum is 8 from position 5. Swap it. Now you can see here, so far up to this part of the array has been sorted. Okay, this part is unsorted. This is what I said. As we progress over the algorithm's processing, a part of the array will become sorted, another part will be unsorted. We will stop with one more operation here. Okay, so I'm going to repeat the same thing for position I equal to 4. Minimum is 12. I'll replace with first position of the unsorted subarray, which is 4, and now according to the algorithm up to this part is sorted. Okay, but if you look at the remaining only one position, it is also in correct position. The value whatever that is there in the last position is already in the right position. So we don't have to repeat the same process for last position, that is finding minimum from this location, from this sub array, which is unsorted sub array, because there is only one element. There is no point in finding minimum and then swapping it with itself. If you do it, the array will remain unchanged, so it is an unnecessary step. So what we have to do is we have to stop processing as soon as the value of I becomes less than n minus 1. You can see here n value is 6. Less than 6 means you will repeat it for this position as well. So we will say less than n minus 1. So this is the stopping condition, not less than n. If you say less than n, it will repeat all the way up to less than 6. That means it will include the processing for position 5. So we have to say less than I is less than n minus 1. So we, in our example, n is a 6. So less than 6 minus 1, 6 minus 1 means 5. So less than 5 means it will stop at this point. So this unnecessary processing for this location can be saved. Okay, no need to do that. Okay, now you can see here the array is completely sorted. Now you can see here how the algorithm actually works. This is the input array, random input array. The result of first iteration is this. You can see here in the result of the first iteration, first location has been sorted, and this is the result of the second iteration. You can see here the first two positions are sorted, this is not sorted. So it goes on until this position. Okay, so we will not repeat it for the last location. So in the exam, if the question is given, consider this array and sort it using selection sort, you need to write these steps. Okay, to summarize, selection sort involves two steps which will be repeatedly performed. Now we will repeat this for position starting from I equal to 0 to I less than n minus 1. Okay, in the next video I'm going to show you how we can implement the selection sort algorithm using Java, and subsequently we can also do the time complexity analysis of the selection sort.